This is a post I have. It's in the Cosmos forum. There, it's called a design for fungible staking derivatives, and it's very much it's a design for how to do the native variant of staking derivatives, and it sort of is meant specifically for the Cosmos SDK because it's designed in such a way that it handles a lot of the oddities that show up in the Cosmos SDK, which I'll walk through now and hopefully make sense. So the forum post is a bit difficult to understand, and so that's why I hope this walkthrough can make it a bit, allow people to understand it much easier. Okay, so the first thing we're going to start off with is at the Hackathon Berlin last summer, Chorus and Sika came up with this delegation vouchers system. And I'll quickly walk through that just for the basics, and then so that way, and then I'll show you why it doesn't quite work for what we want to do in the Cosmos Hub, and then how we go about fixing it. If anyone has any questions, please interrupt in the middle. Yeah. Okay. So this is the delegation voucher system. So let's say a user wants to go ahead and delegate some atoms to the validator. What they would do is they could go ahead and delegate 100 atoms, and what you do is you get back some certain number of shares. Most of this accounting is actually what's already happening in the staking module of the Cosmos Hub. But all we're going to do, the main change we're doing now here is instead of shares just being a number that's accounted for in the, right now, each delegator's shares is just a number accounted for in the state of the staking module. Instead, what we would do is it would actually be a token that's returned to the user. So now they have 100 shares of that validator. And we keep track of the conversion ratio between atoms to shares. And so that way, if another user comes in and deposits 100 atoms, they also get shares back at the same atom to share ratio. So they'll get back 100 shares. So now there's a total of 200 atoms in the pool and 200 outstanding shares. Now let's say there's a 50 atom reward that was added. So, the validator staking, and now there's 250 atoms in the pool and only 200 outstanding shares. What this means is that the conversion ratio now has increased to 1.25 atoms per share, just the number of atoms over the outstanding shares. So what this does is when one of the users says, okay, you know what, I want to unbond half my amount, right? So I have 100 shares, I'm going to unbond 50 of them. So it will go ahead and return to the user atoms at that conversion ratio. So now there's only 187.5 atoms left in the pool, but because it gave 62.5 to the user, but the number of shares also went down because the user unbonded or burned 50 of those shares, right? And so you'll notice that when people bond or unbond, it doesn't ever change the conversion ratio. The conversion ratio only changes when the validator gets rewards or if it gets slashed, right? So if the validator gets 100, let's say you got a slash of 100 atoms, right? It suddenly dropped the current number of atoms in the pool from 187.5 to 87.5, but the number of outstanding shares is still the same. So all that we did now was change the conversion ratio. And so, let's say the user tries to unbond 50 shares, they'll get back a much lower amount of atoms than they did earlier because conversion ratio has decreased due to slashing. So whenever there's rewards, the conversion ratio is always going to be increasing. And when there's a slash, the conversion ratio will decrease. But now here's where the problem comes in. What happens, in the Cosmos SDK, we've designed it such that fees are meant to be able to be paid in any asset that you desire, right? Or at least any whitelisted fee token. And so what happens if the reward is in some other asset other than atoms, right? Let's say it's in 100 photons, not that we know what photons are yet, but let's say it's in 100 photons. And now, look, what does this mean? The current pool has atoms and photons and the shares, but the conversion ratio, like, does that mean that the conversion ratio is 0.58 atoms and 1 photon per share? And does that mean when you want to bond, you have to put in 100 atoms and some photons? Like, it doesn't really quite, it doesn't really make sense. Once you start putting other stuff into the pool, along with the atoms, then you don't really know what the conversion ratio means anymore. And this is important because, let's say someone, yeah, okay. So, actually, okay. So, to solve this, that's why in the Cosmos SDK, we developed this thing called the F1 fee distribution. And so, if anyone is part of the Game of Stakes last year, you might know this thing because, it was causing a lot of bugs and stuff. But essentially, the key of what it's doing, so this is sort of what the delegation struct looks like. But what the F1 fee distribution does essentially is it keeps track of what happened when a specific validator. So rewards are not automatically rebonded. So one thing you'll notice is in the voucher system, this is essentially auto rebonding rewards. But in F1, it doesn't auto rebond the rewards, and it keeps track of, let's say the reward pool for a certain validator has 500 photons in it at time 5. And then you bond into that validator at time 6. The F1 fee distribution system makes sure that you are not entitled to those 500 photons. You don't get a share of those photons. You only get a share of the tokens that enter the reward pool after you bonded. And this is sort of, and conversely, it also makes sure that, if there was a slash that happened before you joined, then you don't get punished for something that, your atoms are not going to get slashed if you join afterwards, right? So that's what the F1 fee distribution does. And we kind of need this to, if we want to have multi-fee tokens, if we want rewards to be able to be paid in multiple tokens, which is, especially when we start to get to like shared security stuff, I imagine that's, that's going to be very necessary, I think, for the UX of the shared security model to work. And so this is sort of how I kind of structure my things. I have my pseudocode. So I have these constants. These are the constant fields of a struct. You have the variable fields, and then you have the capabilities or functions. Like, what can you do if you are the owner of that struct? What can you do with it? So the thing that's important here is the reason that these are you can read the F1 fee distribution spec here. So what we could say is, hey, what if we just turn this thing into an asset? So this is the delegation struct that is already in the state of the staking module. Why don't we just turn this into an asset so that way, instead of it be like, instead of the from delegator being in the state saying saying, okay, who owns this? It's, this person. What if we just make it into an NFT, right? Where whoever is holding the NFT is the delegator, right? So if I give it to someone else, then they would become the delegator. So why is this non-fungible though? Why is this non-fungible though? It's non-fungible because of that last withdrawal time that the F1 fee distribution needs. So because, let's say I delegated to Sika at, time 10. Last time I withdrew was time 10, but, let's say someone else, Felix, delegated to Sika, and he hasn't withdrawn his reward since like time 0, right? The fee distribution system has to keep track of when was the last time each person withdrew their rewards, so that way it can, when Felix withdraws, he'll get more rewards at that time, because it has to also give him the pro rata rewards for time 0 to 10, while if I withdraw, it'll only give me the pro rata rewards from my last withdrawal time to the current time. And so because of that last withdrawal time is different for every delegator, these delegation assets are non-fungible. And what is the issue with them being non-fungible, right? So, you can trade them OTC, which is fine, right? Like, I could go up to, Brendan, I can be like, hey, look, here's my Delegation NFT. You can see how many atoms on there. You can see how many, when's the last time I withdrew, and we can come up with a deal ourselves. But you can't put it really into like a Uniswap style thing because they're non-fungible, or it'd be even very difficult to put them into like an order book like exchange as well. It really only works on like a OTC system. And it's also much more difficult to reason about and thus much more complex to use in DeFi. So imagine like, Kava CDPs. We wanted to use these as collateral in the CDPs. Price oracles would have to give the value of each of these delegation NFTs separately because they're going to have separate values because their last withdrawal time is different. So, okay, so here's solution number one. What we're going to do is we're actually going to keep a delegation struct in state, but we're going to create a separate asset called a delegation claim, which is still an NFT for the moment, but we'll explain how to get that finish turning it fungible. But for now, it's still an NFT. But what it does is it refers to a specific delegation in state. So and what you can see is the functionality it has is this ability to change the withdrawal address. So let me walk through how that works. So let's say Alice wants to delegate to this validator A, right? So she'll go ahead and say, okay, I'll delegate 100 atoms. And what will happen is in state, it'll create a new delegation object, which, let's say the ID is A1. It's the first delegation to validator A. It's to validator A. The withdrawal address is Alice. It's 100 shares. And the last withdrawal time was time 50. Now, let's say it's time 100 now, and the validator has accumulated some rewards. So Alice can go ahead and say, okay, withdraw. It will send her back some rewards, and it will update the last withdrawal time to 100. Now, let's say she wants to unbond 50 shares. It can do that as well. It will unbond 50 atoms, and it will reduce the number of shares. That still all works the same. Now, what happens when she wants to sell this asset? She wants to sell ownership of this asset. What she can do is she can go to Bob and basically sell her the NFT that is a claim on delegation A1. Now, Bob is now the owner of this, and he can go ahead and unbond if he wants, and he'll get out 10 atoms. Great. So now the shares went down by 10, and he got back 10 atoms. But let's see what happens when he tries to withdraw. He says, okay, I'm going to withdraw rewards. The last withdrawal time went up, but you'll notice that the withdrawal address is still Alice. So the rewards actually get sent to Alice. So what actually needs to happen is when Bob receives the asset, he needs to first say change withdrawal address. And what this does is it first takes all the rewards that have been accumulated thus far, gives them to the last withdrawal address, which is currently still Alice. Then it changes the withdrawal address to Bob, and it resets the last withdrawal time. So what this means, and gives him, and then he can withdraw. And so what does this mean? Like, why are we this makes it so it doesn't matter which, and let's say you have the option to buy the delegation claim from Alice or Charlie, right? And they both have the same number of bonded atoms. Let's say it's 100 shares, right? But Alice has not withdrawn in months, while Charlie has withdrawn, just yesterday, right? In the previous system, you would want to buy Alice's, right? Because, there's more rewards there. But what we've done here is it doesn't matter whether you buy Alice or Charlie's claim, because when you buy either one of them, the first thing you do is you change the withdrawal address by sending that function. And then it takes all the rewards that have not been claimed yet and gives them to Alice or to Charlie. And then you only start to start accumulating the rewards from the point after you call change withdrawal address. So what this does is it makes both of these assets fungible because they both have the same capability, which is to start accumulating rewards. It doesn't matter what rewards are already been accumulated to the past owners, because those will get given to the past owners. And so that kind of makes them both sort of fungible. Now, this change withdrawal address, I mean, one of the cons of this is, let's say you have, so the struct is on the Cosmos Hub, right? Let's say we're staking on the Cosmos Hub, but we're on a separate chain, right? And we've moved that NFT, Alice has moved that NFT onto a separate chain. She can, sell Bob the delegation claim. But the problem is Bob is not going to start earning the rewards because the withdrawal address is still Alice on the Cosmos Hub. So he actually does need to IBC it over to himself on the Cosmos Hub, change the withdrawal address, so now it gets set to Bob, and then he can, send it back to himself over there. So this is one of the more, it is kind of a little bit annoying that you have to do this, but this is sort of how it has to be done so that the withdrawal address in state has to be, you have to be able to update it. The question is, do you always need to change the withdrawal address? I would say not always. So sometimes, let's say you're trading really quickly, right? And let's say you're on this other chain and you're just trading really quickly on like Uniswap, you're doing some arbitraging or something. Maybe it's not even worth changing withdrawal address because like the amount of rewards you get in the time that you're like holding the asset, maybe it's actually barely any rewards, like not maybe because you're trading these on like a minute-to-minute basis. So maybe the rewards aren't actually that worth that much. Really, it's like the potential for someone else to buy that asset and start claiming the rewards themselves is what gives it value. And so, maybe it might not even be worth like the IBC fee to do that. Weirdly, so for the buyer, like I said, it doesn't matter to the buyer. It's the ability to change withdrawal address that makes it valuable. For the seller, it is sort of in this weird kind of like, it's a little bit odd because it is in the seller's incentive to sell to a lazy buyer who will be slow to make the change. So let's say I'm Alice. I can sell to Bob or I can sell to Charlie. And let's say I know Charlie is like really lazy and he's not gonna actually go and like update the withdrawal address for like a few days at least. I would rather, and Bob, I know, he's on top of his thing. He'll go do it immediately. Weirdly enough, I'd actually rather sell to Charlie because for those few days he takes to update his withdrawal address, I'm actually earning extra rewards even after selling the asset. But, really, the fungibility really comes from the buyer's perspective because usually it's if you think about it in a Uniswap market, as long as to the buyer it's the same, that's what really, sort of matters. So, and if you are long-term holding an asset, then yes, it is worth going to change the withdrawal address. Okay, so great. We're almost done. The only problem is here, it's still a non-fungible asset, not because the withdrawal address isn't what matters anymore. It's only now non-fungible just because the shares are different, right? Let's say, Alice has delegated with, 100 atoms and Charlie has delegated with 50 atoms. Obviously, their delegations are not worth the same amount, and thus their delegation claim can't be worth the same amount. So to make this fungible, we want to turn these into tokens. And so what we can do is the final iteration of this model is we say, okay, we're still doing the delegations as a struct in chain. We're going to stop calling it the withdrawal address. We're just going to call it the owner now. And we're going to create this delegation share token. So you can think of this like a denom. The denom will be like, it'll be like the delegation owner name concatenated with the validator name and So these are the capabilities you get when you own the delegation share. So once again, let's walk through it because that will probably be much simpler. So let's say Alice, she goes ahead and delegates to Sika here, right? So she'll go ahead and delegate 100 atoms. And what she'll get is, can everyone see the thing at the bottom? Or is it blocking it? Okay.
100 Alice Sika shares.
Yeah. Okay. Cool. Yeah. So Alice gets. Yeah. Sorry, my Zoom thing was blocking the bottom of the screen. Okay. So Alice gets a. So when she delegates 100 atoms, she'll get 100 Alice Sika shares, and in state there'll be a state object that says, okay, there's this delegation object. The owner is Alice. It's 2 validator Sika. The shares are 100, and the last withdrawal time is 50. What she could do is she could sell 50 of those Alice Sika shares to Bob. And she can go, and if she tries to, now she'll say, okay, I'm going to unbond 100 atoms. The system will be like, no, you can't do that. You only have 50 Alice Sika shares. So when you unbond, you have to actually, burn your atoms along your shares along with it. So now she'll say, sorry, the text here is wrong. It should say unbond 25 Alice Sika shares. And then it will, decrease the number of shares by 25. Now Bob can, once ahead, similar to the change withdrawal address, now we just call it change owner. He'll say change owner and pass in 50 Alice Sika shares. And he'll, burn those tokens. And what that will do is it will create a new delegation struct in state with 50 shares. So it decreases 50 shares from Alice's. So now she's back down to 25. And it creates a new one for Bob. And now Bob gets 50 Bob Sika shares. And so these represent, claims on that delegation. And the rest of it still works sort of exactly the same. The rewards now are kind of just done, based off of your own last withdrawal time and whatnot. So 2 pesky problems in this. One, it's that tokens that are in an active wait, sorry, really quick before we go into that. So you'll see that, these Alice Sika shares and Bob Sika shares, while they are separate assets, right? They are separate denoms. They are still like truly fungible with each other. They both, because let's say I'm Charlie, I can buy 25 Alice Sika shares or I can buy 25 Bob Sika shares. It doesn't matter to me. I'll buy either one because as soon as I get them, my intent is just to go and change the owner of them and create a new delegation and to go create 25 Charlie Sika shares. And so one thing we'll have to do in the Cosmos SDK is provide abstractions around denoms such that you can. I have an issue open for this in the Cosmos SDK where you can basically say that okay, both these 2 different denoms both share the same property, and so let's treat them the same for this purpose. So for example, let's say you have a Uniswap market, right? You want it to be, I don't know, DAI to Sika shares. You want it, so you'd make it in that Uniswap market. So it doesn't care whether it's getting Alice Sika shares or Bob Sika shares or Charlie Sika shares. It will just care that it's getting blank Sika shares. And so that does require some modification, like some updating to how assets work on the SDK. So yeah, 2 pesky problems. One is if a token is currently in an active redelegation from another validator, let's say, when I do these tokens, not only can I unbond, I can also redelegate, right? So I can turn Bob Sika shares into, so Bob can turn Bob Sika shares into Bob Chorus shares. He just has to call a instant redelegate and pass in his 50 Bob Sika shares, and we'll mint him a new delegation struct where the owner is still Bob, but then the 2 validator is Chorus. The problem is when you're in this active redelegation for the period of 1 unbonding period, you are slashable for both the validator's faults. So if Sika faults, you're slashable for them, and if Chorus faults, you're slashable for them. And thus these, for that short period of time, for that first unbonding period, the Bob Chorus shares are not fungible with other, Charlie Chorus shares because Charlie may have been delegated to Chorus for, ages, right? That's one. And number two is that newly bonded tokens are not subject to slashes that happen before they start bonding. So, Bob changes to Chorus, and Chorus had slash at block 10, but he changed at block 15. And so, there's some weirdness around that. So the simple solution to both of these problems at once is just say a delegation cannot issue derivatives until it has been bonded for at least one unbonding period. So let's say I bond tokens to Chorus. I have to wait 3 weeks before getting the derivative, the shares of them. And same with an instant redelegation. If I rebond from, Chorus to State Capital, I have to wait 3 weeks before I get the State Capital shares. Yeah, that's about it. Thanks.
That was great, Sonny. Thanks, really clear. Can you just go back to that last data structure there of the very last solution?
Yes.
So this owner is down as a constant there for the delegation share.
Right.
But it's not constant, is it?
We're no longer changing the owner of a delegation struct when you change owner, but we're rather just creating a new delegation struct.
Okay.
And so that way, let's say Bob had bought all of Alice's tokens and decided to change the owner of them. It will just, once Alice's struct hits 0 shares, it will just be like pruned from state. So it'll just disappear.
Okay.
Hey, I have one question, which is why do you need the last withdrawal time? And whenever someone is transferring their delegation shares, why do they need to change the last withdrawal, the withdraw address basically? Because you can keep the withdrawable tokens in a separate pool, so that the validator pool tokens can be fungible and easily transferable.
Sorry, can you repeat that? I didn't quite understand the question.
So instead of having the withdrawal address, you can keep those withdrawn token into a separate pool.
Mm-hmm.
So then, let's say if Bob is transferring 50 tokens and he has withdrawn let's say 50 tokens already, then you don't need to have the last withdrawal time or withdraw address, basically, because these both are separate pool, and he can just transfer the 50 tokens which are already bonded.
One of the key designs of the fee distribution in the Cosmos SDK is that when the rewards for to Alice, so the rewards of the Sika pool, right, are actually all in one pool together. The Alice rewards are not kept separately from the Bob rewards, and
I understand that part.
Right, and so that's why you need the last withdrawal time to do the account, because we do lazy accounting. We don't separate them. We use the last withdrawal time to calculate how many rewards from the overall pool should go to Alice, and that's why we need to keep track of that last withdrawal time. We don't want to when on a blockly basis. We do never want to be iterating over all delegators to distribute rewards to them.
I think not really, because if I understand the conversion rate, it should handle the part where you don't need to have the last withdrawal time.
Where there's no more conversion rate happening, right? So for now, we're assuming that all rewards are going in. So there's a separate delegation pool versus the reward pool, right? So because we're not auto rebonding atoms now in this version here, then the one-to-one between shares and atoms is always one-to-one.
I might be misunderstanding something. So let's say we have 2 variables for one validator delegations, right? So which is the one is active stake, which is bonded atoms, and another one is reward. So whenever there is so let's say for whatever reasons the rewards come, you just keep adding into the rewards. So now you have active stake plus rewards divided by whatever shares you have minted.
Yeah.
So in that case, you don't need to like keep track of last withdrawal time.
No, because let's say there's 100 tokens in the pool, right? Alice decides to withdraw her rewards right now, right? So she gets 50 of them, right? And so now, but she still has 50 shares, right?
Oh, I see.
And so now let's say later on, there's another 50 atoms re-added to the reward pool. She can't go ahead and say, oh, I have 50% of the shares, let me withdraw another 50. Because no, she only is deserving of 25 of them right now. Because a previous 50 are owed to Bob, and then half of the new atoms, 25. So Bob is actually entitled to 75 of them. Does that make sense?
Yeah, now I get it. So in that case, like, why don't you just burn the shares actually?
Because
so let's say
the shares are shares of the bonded pool, not of the reward pool. So when you withdraw rewards, you don't burn shares.
I understand it. So in my design, what I did was basically, so let's say initially you bought 100 shares. So let's say whenever you are withdrawing something, so right now let's say the exchange rate is 2. So for one shares it's 2. So let's say you are withdrawing 100 tokens, then I'll burn 50 tokens actually. So in that case, we don't need to manage the last withdrawal time.
So the design that you seem to be describing is the original like delegation vouchers from last summer. But the problem here, like I mentioned, is it only works if all rewards are in the staking token, which might be the design of the but for the Cosmos Hub, it was very much a design decision. Like, as far as I understand, it's still probably a design decision that we want rewards to be able to be paid in other tokens other than atoms.
So if I also just wanted to talk a little bit about, because after we worked with Sika together in last June, we talked about this issue, and there was another hackathon in July, and we kind of took a different approach to solving sort of the same problem. So I also just wanted to explain a little bit what we did back then. So, as Sunny pointed out, right, the original design works kind of very nicely, where you have to share, and then you have this atom pool that gets filled up, and anyone can take any of these shares, they're perfectly fungible, and just redeem it for this accumulating atoms. And you can take it to other chains. You can use it there. There's no need to bring it back. There's no need for withdrawal address and those kind of things. And as Sunny pointed out, this kind of starts falling apart when you have basically the income starts to be in various different tokens. And I guess this will depend a lot on what's the network, what's their goal, and if they do want to have fees in various different tokens, but presumably some will. And for Cosmos, there's very much the idea, right, that if you're routing basically packets of tokens across many networks, that you can pay in this native token of whatever you're routing through. So then, totally is the case, right, that in Cosmos, it will make sense to accept fees to be paid in various different tokens, right? And so then you have this challenge here. So we thought there is a sort of a very elegant way of solving this problem, as well as another problem that I'll get to in a second. And that way is basically to say all of those non-atom rewards, they go into kind of a separate pool, and they're auctioned off on chain for atoms. And that sort of happens, continuously and automatically. And the frequency that this happens would depend on kind of how much those fee revenues would be. So let's say it's 0.1% of of the rewards that, you know, atoms represent block rewards, right, then probably doing it like once a day would be fine. So what would happen then is that, you know, when this auction happens, you just have some additional atoms that get paid into this reward pool, and it basically makes kind of like no difference for these shares. It's not noticeable. Of course, there is a little bit that effect if you have this kind of mechanism that you have with shares of companies as well, where, you know, if you own a share like right before dividend gets paid, it's worth a little bit more than afterwards. But here, you know, you would essentially have sort of dividends from like non-atom income, but you could pay these dividends, you know, on a daily or maybe every few hours or something basis. So this effect is going to be so tiny, it will be, you know, it could be ignored. And so then you just have these extra rewards, right? And then basically the old design works, and, you know, there's much more simplicity with the design. You know, you have perfectly fungible tokens. There are no NFTs. There's no withdrawal ladders. And so I think there's a great benefit from that side, just in terms of keeping it very, very simple. But there's also a great benefit if you look at it from another perspective, which, let's say you are now staking atoms on the Cosmos Hub, and you're earning atom rewards. And, you know, that's nice, right? Because like that's what you bought in the first place. So getting more of them makes a lot of sense. But now let's say you're also earning like some other tokens, and maybe down the line, you're going to have like 5, 10, 50, 100 different tokens that people can pay fees in. So what you essentially start to have is that all of these delegators are going to get like minuscule amounts, basically dust, in like lots of different tokens. Of course, that's like a nightmare, right? Like you don't want to have like atom rewards as well as 100 different tokens in these tiny amounts that then, you know, you have to go and try to convert into some token that you actually want. So I think from also a user experience perspective, you don't actually want to get rewards in like lots and lots of different tokens. It's much nicer if you just get more atoms. Of course, this is all a little bit specific to the Cosmos Hub and sort of to the specific use case that the Cosmos Hub is trying to fill. But that's kind of the, you know, the alternative approach that one could take. And, you know, for these on-chain auctions, you could use something like Uniswap, so it would be very, very simple to do that. And yeah, so that's also something we built in a hackathon in Seoul last year. So yeah, I just wanted to share that kind of as a sort of another version, another alternative design for delegation vouchers that, you know, we did some work on.
Right.
I have. Sorry, go ahead.
Oh no, yeah.
No. I have some questions in regards to fungibility across validators. So like the basis of validator fungibility. So like the value is equal because you basically can switch validators for these delegation vouchers, right? But I was just kind of wondering. Sorry, go ahead.
Well, it's not. The goal here was fungibility between Alice shares and Bob shares. It was not about fungibility between validators, and it's not really intended to be fungible between validators. I mean, it will be a little bit because of that instant redelegation, because you can buy Alice Sika shares and change them to Alice Chorus shares. They're close to fungible, but they might be slightly different because of slashing risks, which is what you want. You want these to not be fungible because you want the shares to be somewhat reflective of the slashing risk of each validator.
Yeah, and just kind of as a follow-up question to that, like, do you think these shares, because like we have, specific to the Cosmos Hub, there's a limit of like 7 redelegations, as far as I understand. So, you know, obviously, a specific validator share would be, could be less in value if it's in that part of that 6 redelegation period. Like, so that will have to account for that as well.
Well, this is why this kind of goes back to this piece of let's just make it so if you've been bonded to a validator for less than an unbonding period, just no shares at all. That way we get rid of all edge cases.
Okay, cool. Thank you.
I realized I actually forgot this one slide. Basically, a couple of things is one, we can still, here I actually I made it so that, okay, new rewards are going directly into the reward pool, but there's no reason actually in this design why you can't still auto rebond all Atom rewards and allow other token rewards to use the F1 fee distribution. So that's completely okay still. We would need to decide whether peripheral capabilities like voting, right? Like your voting rights, is that, so let's say you're in this case, right? Where Alice has already sold some 50 of her Alice Sika shares to Bob, but Bob hasn't called change owner yet. Does Alice only have the voting rights of 50 atoms, or does she have the voting rights of 100 atoms? That's a decision that has to be made. I mean, it can go either way. I personally think that she should get all of the voting rights until Bob changes owner, but no, that's my opinion. Two, we can probably make it so the transfers that happen on the hub itself automatically cause change owner. So when Alice sends to Bob, it could just trigger a hook that automatically changes the owner to Bob. So that way you only have to manually call change owner if you're doing the transfer on a different chain other than the hub. And then finally, we should add a time lock module. So if this kind of like not specific to this design, but this is just equipped for something for like all staking derivative stuff, where if we're having staking derivatives, we should have a system where, let's say as a validator operator, I want to show that I'm long-term bonded. I can take my derivatives and put them in a token lock module, which basically prevents me from moving them for like, it basically reinserts me into a forced unbonding period, so I can't move them for at least like 3 weeks notice or something like that. So that's a separate point. But yeah, so I agree that. So I think that either this model or the auction model, to me, seems like the right way to go. I do see the benefits of not having so much dust and stuff and all these different tokens, but at the same time, then in that case, we do have to guarantee that there is a market for people who are buying from the auction. So you need a set of a participant set who's willing to play those auctions.
Oh, if there's value, then
yeah, totally.
Will, right?
Yeah. But it comes to how liquid it is, right? Because if there's less people playing that market, then and not actually buying they might be buying from the auction at a discounted price, which means the validators are getting less atoms than the fee tokens that they sold off for.
Yeah, sure. I mean, maybe if it's very liquid, like let's say it's a discount of 10% or something like that. I mean, as soon as it gets a substantial amount, I'm sure that there would be a discount that's much less. But even if it's a discount of 10%, that's probably still economically better for me as like a delegator than if I get like lots of little coins and then I have to go and like transfer them somewhere, liquidate them. I'm probably gonna pay more in fees and certainly in hassle to do that.
Mm-hmm. Yeah. You also need a fairly liquid amount of atoms. That's the other thing, which maybe is not a big issue, but you will need liquid atoms. My issue is less with the fees on the hub. My issue is more when we get to shared security. I imagine that like a chain that's being shared security might want to give some of its rewards in its native token. And so that's where I think that the issue becomes a bit greater than in the fees.
Sonny, there's a few questions about subkeys there in the channel. Do you want to just introduce the idea of subkeys and maybe talk a bit about how subkey functionality could help this design, make it more flexible?
So as far, so the whole subkey stuff has gone quite a bit, progressed quite a bit since I worked on it, but, subkeys are pretty independent design, thing in my opinion. But essentially, the idea of subkeys was just that an account can provision additional keys other than its master key to do different functionality. So I can basically, if I want to provision a new key for, I don't want, one of the annoying things about like, participating in Cosmos governance is I have to like, Dave and I have this like complex multi-sig procedure to sign all transactions for security reasons, but it's really annoying for like governance voting. It would be nice if I can provision a specific key that all it's able to do is vote in governance and nothing else. And that one I can keep a little bit more hot. And so that's what the subkey system is designed to do, where like our validator account, it could say, okay, this key is allowed to do voting only transactions. There might be ways where it relates to this, where maybe, one of the ways that, one of the things that you might really want is a new key that all it's allowed to do is call withdraw rewards, because that way you could just constantly, maybe you can only call withdraw rewards and rebond. So that way you can just have that as a hotkey, and every like you can keep that on your phone if you want to, and you can just like regularly just withdraw rewards and then rebond the rewards as stake. So that's something that kind of helps with the subkeys, but for the most part, it's a pretty independent thing to this.
Okay. Hyung, do you want to jump in there? I see a few comments just related to the subkey functionality. Do you see this working in a different way?
Okay, so one of the expansion of subkey from our team is to build a subkey which does not have a private original private key, but only having a member key. So it's a subkey, only subkey, but does not have a main private key. So if you have only one member key, then a transaction to change this member key can be seen as a transfer of ownership from myself to another one. So that is our analysis of applying this subkey thing to transfer locked assets. So if you can send the ownership of an account to another person, then you can trade these assets. So you can just trade this account against some liquid assets. So that is our approach to make locked asset, which is one of the locked asset is delegation. So that is how we approach to liquidate this locked asset.
How would you like use this in a DeFi sense though, right? Like how do I assetize the ability to change the subkey ownership, right? Like one of the goals of the staking derivatives is you wanted to make it easy to use in DeFi purposes, right?
Yeah. So we already built a POC of OTC market to trade staked atom against liquid atom. So the trade will be done via atomic swap. One side of atomic swap will be a transfer of ownership. The other side will be a transfer of liquid atom. So if both sides agree about the contents of the agreement, then they can build an atomic transaction so that this transaction will execute these two directional transaction at the same time.
Right. So like I said, like, I can see how this works in an OTC style system, right? And so this kind of what this is essentially it's an NFT model of doing this. But the problem with the NFT, how would I put this into a Uniswap contract, for example, right? Or how would I put this into an order book? Or how do I get Kava CDPs? Like how do I get the price oracle data of each of these NFTs independently?
Yeah, so this solution does not solve a fungibility issue. So
Right.
each of the account is like an NFT, it's non-fungible. So we cannot solve any fungibility issue for this.
Right. And yeah, so if we don't want fungibility, there are like easier ways we can actually do something much simpler like one of these earlier models, but where we just this would actually be a very simple change where we already have this struct in state. We just have to turn it into an asset where instead get rid of the from delegator as in state and just say, okay, it's whoever holds the asset is the delegator. That's pretty simple to do and probably safer than transferring ownership of an entire account because there might be other things that are in that account you don't want to transfer ownership of. But it's for me the fungibility is a key design goal if because I really want these things to be usable in different DeFi applications.
Yeah, I agree.
Okay, I'll try and get a couple more questions, as I know we're getting short on time here. So Colin's asking about, can we separate out the rewards? So I would keep my stake tokens, but I'd be able to sell on the rewards to somebody else. I think this kind of goes back to what Felix was talking about earlier of an interest rate swap. So I'm basically selling the rewards onto somebody else, but keeping the actual asset. Sonny, how do you see that fitting into this model, or you think that's a completely different design?
Yeah, sure. So this is actually one of the things we were thinking about back in Berlin, but the problem is then the reward vouchers would still have to be NFTs because it still falls into the same problem. It has to keep track of last withdrawal time, and so you'd have this weird situation where the staked vouchers are fungible tokens, but the rewards are NFTs. But it's like, what's the point of the staked derivatives if they don't entitle? So let's say I have I delegated to Chorus, and I have 50 stake fungible token like vouchers, and then I have an NFT that represents my delegation to Chorus, and I send my 50 tokens to Brendan. But if the NFT is still in my name, the reward voucher is still in my name, what are those 50 tokens like even representing anymore at this point? Like I guess all you could do with them is unbond them, but that's kind of like, I feel like the goal is you want the reward and the staking amount to be linked, because otherwise why would someone buy them? All they're buying is then they're just buying atoms with no upside because they can't earn rewards, but they only have slashing risk.
Yeah, I mean, so the way I look at it is this. If I need liquidity, but I want to keep the underlying, I do believe that there will be people that will basically create discounted cash flow valuations for the future value of what those returns could be, similar to like an annuity stream or a fixed income security. And for the first time ever, you can actually separate the two, whereas today in the financial world, you can't separate the two. They're inherently linked. So I think it's important that there will be people in these new business models that we're going to create that will be looking for programmatic cash flow. And then there will be methodologies put in place to evaluate programmatic cash flow. And as someone who owns the underlying, who's long it, if there is anticipation from people of increased staking rewards, if staking rates become a new risk-free rate of a new global financial system that things are built on top of, there will be people who just want like fixed income purchasing. They may not want the underlying, they just want to be entitled to that revenue stream.
So what I would say is I agree with that. So what you could actually do is, once you have this delegation share token as a primitive, then you can actually put these into you can actually split these assets if you want to, and like separate out the unbond and redelegate capability from the change owner capability. So you can imagine, let's say I put I created a smart contract. I put delegation share tokens into that smart contract, and that issues so I'm still the owner of the delegation share, but it issues a new token, which only allows someone to change the owner. And so that way you could go ahead and buy that change owner token. And using my shares out of there, you could go ahead and change the owner to yourself, and you'd start earning those rewards and then you could sell that change owner token to someone else. They can start earning those, and they can change the owner, so they start earning the rewards, but they never have the ability to unbond the underlying. And that's one way you could do it.